Now I want to look at the last type of conic section that we're interested in, the hyperbola. Now remember, a hyperbola happens when you take a vertical plane and you cut across the cone such that you have these two symmetric curves. Right, so that's what's happening in theory. But to be more precise about it, this is the way we define it. A hyperbola is the set of points in a plane whose distances from two fixed points called the foci, sound familiar, have a constant difference. Now, why does that sound familiar? Well, because it's almost identical to our definition of ellipse. But in ellipse, the fixed points have a constant sum, right? So that keeps them fixed and around this orbit of the center. But in hyperbolas, it's the difference that's always the same, and therefore they go shooting off towards infinity. So even though I didn't draw them in here, just like with the parabolas, there's little arrows going this way. All right, now there's two types. For all of these hyperbolas, the center is hk, the major axis length is 2a, and the minor axis length is 2b, and c squared is a squared plus b squared, right? Because this is not an ellipse, it has different formulas. They're related, but they're not the same. So another thing to note is that the size of a does not determine whether the hyperbola is horizontal or vertical, unlike in ellipses. So in ellipses, you could tell the major axis because the major axis was always the one that was larger, right? A was larger than B, period, no matter what. And because of that, major axes could be horizontal or could be vertical depending on the size of your A. Hyperbolas don't work that way. Hyperbolas, it's dependent upon what's connecting your vertices. So you have a vertex over here on the left and one on the right. If they're left and right like this, then the major axis is horizontal. In which case your major vertices are h plus or minus a comma k, your foci are h plus or minus c comma k, and your slant asymptotes, these diagonal asymptotes, which is what this curve is approaching as it heads towards infinity, are right here. All right. Now, that could be the case, or this could be the case. Now, you can tell this is horizontal because if you see, this has got x in the front. See that? And it's a minus. So unlike with ellipses where they're added, so it's commutative, hyperbolas are not. So whichever one's in front, that will create your horizontal asymptote this way, right? Or if it's y in front, that will be vertical. So your major axis will go that way. They can be small, right? It's possible for your major axis to be smaller than your minor axis. That's actually happening in this case. And that's okay because that's not really what determines whether it's major or minor. What determines whether it's major or minor is if the hyperbola is facing up and down, which means vertical, which means it must have been y minus k in front, or minus k squared. Or if it's horizontal, which means it must have been x minus h squared. And if you're interested, I do have all of these on Desmos for us. And these are posted in Canvas. Up in the technology page, there's a link to all the Desmos graphs. But you can see all the different, oops, I moved the whole thing. Sorry about that. But you can see the setup in a different way that way. All right, let's answer some questions now. So we have to find the center, the foci, the vertices, and the asymptotes of 9x squared minus 16y squared equals 144. And if you're thinking, that sounds familiar, yes, it should. Because we did a very similar problem before where it was added. Adding makes it an ellipse. Subtraction makes it a hyperbola. But either way, we do want it to be equal to 1 because that's the standard form for both ellipses and hyperbolas, is that it's set equal to 1. So we're going to divide by 144 and see what happens. So let's divide everything by 144. That would get us x squared over 16 minus y squared over 9 equals 1. All right, so we now know x is in front, right? So it's x minus h squared over 16. So we know we're dealing with a horizontal major axis. So this one. So we know a squared is equal to 16. So let's do that. A squared is equal to 16, so a is equal to 4, right? The square root of 16. B squared is equal to 9. So B is equal to 3. Now, if we want to be able to find things like the foci, we're going to need C. So we'll need to take a moment and figure that out. So we know that C squared is equal to A squared plus B squared, right there for a hyperbola. All right, so that means that we have 4 squared, which is 16, plus 3 squared, which is 9. And when we add them up, we have 25. So C squared is equal to 25, so C is equal to 5. All right, the only other piece that we need is the center. So, and it asked us for it, so I'm just going to write it over here. Now, if you look here, there's no H and no K added onto these. That means that our center, which is HK, is 0, 0. There's the center. All right, so now what about the foci? The foci are, let's look at the formula, H plus or minus C comma K. We would use this one because we're looking at a horizontal major axis. So let me write that. So it's H plus or minus C comma K. K is 0, right? H is 0. So C is 5. So this would just be plus or minus 5 comma 0. All right, now what about the vertices? The vertices are H plus or minus A comma K. So I'll write that down, H plus or minus A comma K. But again, H and K are both 0, so this is particularly easy. Right? So A was 4, so it's plus or minus 4 comma 0. All right, now what about the asymptotes? Technically, they're slant asymptotes, but that's okay. You'll know that when you write them. So y is equal to plus or minus b over a x minus h plus k. Again, you have to refer to the formula sheet for these because you're not going to remember it every time, but this is the one for a horizontal major axis. This is the one for a vertical major axis. So they're similar, but they're not the same. So this is where 3 comes in. If you were wondering, like, why did we find B? Well, we found it for the sake of finding C, but we also find it for this. So y equals plus or minus 3 divided by 4, and then it's actually just going to be x, because h and k are both 0. And there we have it. All right, let's see if we can go backwards now. So this time we have we have some indications of what's happening. So we have to find the foci and equation of the hyperbola with vertices 0 plus or minus 1 and asymptote. Sorry, I just realized there's a couple things going on. So this should have been a comma right there. This is a typo. So it should be a comma. So it should be 0 plus 1, 0 minus 1. And then I drew a little picture of that. And you can tell because it's 0 plus 1, 0 minus 1 that it has a vertical major axis. Now, the vertical major axis means that, well, all major axes, the length of it is 2a. Now, I can tell how long it is, though, because this is a distance of 1 and this is a distance of 1. So in this case, it's equal to 2, so a is equal to 1. Actually, let me write that right here. All right, so I know A. Wonderful. I can also tell because the vertices are centered right here, right, around the origin. I can tell that my center is right there at the origin. So the center is HK, which is 0, 0. All right, so I know that A is 1, and I know H and K are 0 and 0. So that's wonderful. Now, what about my slant asymptote? So that's the other piece of information that they gave me. So if I use that, the slant asymptote, let me write it in orange here. The slant asymptote, if we look at a vertical major axis hyperbola, the slant asymptote is plus or minus a over b x minus hk, but h and k, of course, are 0 and 0. And you can see that not only in the graph, but you can also see it in what was given as the slant asymptote. So they're telling us that it's y equals plus or minus a over b x minus h plus k. That's the standard form. But they also tell us that it's equal to y equals 2x. And therefore, we know that a is 1. So let me write it this way. A over b, well, 1 over b is equal to, that's a 1, right? 1 over b times x is equal to 2x, right? Because I know that the a is 1, right? Since a is 1, I can substitute that in, and I can use this to solve for b. So 1 over b is equal to 2. Therefore, b is equal to a half. So if you multiply both sides by b, right, so 1/2 is equal to b, and then divide by 2. All right, well, to come up with the equation, we have everything we need, right? Because to make the equation, you need y minus k, which would be 0, so I'm not worried about that. So y squared over a squared, which is 1, plus, oh, excuse me, minus, it's a hyperbola, sorry. Plus for ellipses, minus for hyperbolas. Minus x squared over 1/2 squared. So 1/2 squared is equal to 1. In other words, y squared minus, well, this is x squared over 1/4 equals 1, which would mean y squared equals 4x squared, or minus 4x squared equals 1. There's our equation, right? So we put all of these three pieces together, right? The asymptote, the axis, and the center to figure out this equation. For the record, the reason this is 4 is 1 divided by 1/4 is the same as 1 times 4 over 1, which is 4. Right? That's why that's working out. Just a little note, a little algebra note. All right, now we haven't answered the question fully because we have to find the foci. And the foci won't be hard as long as we can find C, right? Because we need C to be able to find the foci. All right, well, C squared is equal to A squared plus B squared, right? So this is finding the foci. So C squared is equal to 1 squared plus 1/2 squared, which is equal to 1 plus 1/4, which is 5/4. So C is equal to plus or minus the square root of 5 over 4, which is really plus or minus the square root of 5 divided by 2. All right, so then the foci, the formula for them is right here. H comma k plus or minus C, right? Because we're doing a vertical one. So it'd be H k plus or minus C. But H and K are again zeros, so I'm not worried about them in this case. So it'd be 0 comma plus or minus the square root of 5 divided by 2. There's the foci. And we've answered both questions. We found the equation and we found the foci.